I want to give an example of a certain kind of simplification that turns out to be kind of a cute hack through certain kinds of calculus problems. It involves trigonometric and inverse trigonometric functions, where many times if you are composing an inverse trigonometric function, some simplification is possible that makes the function formula a lot cuter, easier to work with. Okay, so it involves really deeply understanding what arctan means and understanding, if you drew a triangle, what this x over 4 represents if you have arctan. Okay, so I'm going to draw just a rando right triangle just as a visual aid. And what I'm trying to say is, let's make up a letter for the angle that's involved here, like theta. And so tan theta is going to be O over A, SOHCAHTOA. And what that means is arctan of O over A equals theta. That's the essence of an inverse trig function. It's just an inverse function. So the O over A comes in and the theta comes out. Okay, so what I'm trying to say here is this is how I label my diagram. I have theta here as my angle, and tan theta equals x over 4. So the x is the opposite, and the 4 is the adjacent. So here in this diagram, you can see how the arctan of x over 4 is equal to this mysterious theta. Well, that means that I need to know what sine of theta is, right? Because if this represents theta, I'm taking that theta and putting it into sine, so I need to know sine of theta. Well, in order to do that, I need the hypotenuse. Easy to do, Pythagorean theorem. And once I know the hypotenuse, sine of theta is really easy. So that means that this thing simplifies to x divided by radical x squared plus 16.